Today we shall start our discussion on Java applets. Now, you may be knowing Java, like JavaScript, is also an object oriented language. In fact, Java is a more elaborate language. It is a complete language and you can use Java to develop any arbitrary kind of application, however sophisticated it may be. Now, in the context of internet, we talk about Java applets. So, we shall first be talking into the language Java in general terms, then come to the point why we use Java applets and what are they. So, Java applets, this is our topic of discussion. The language Java, to talk about the history, first originated at Sun Microsystems by a small group of people who were carrying out brainstorming sessions in trying to develop a new object oriented language that primarily their aim was it should be suitable for consumer applications. They were developing very small and sophisticated instruments, games, consumer applications, appliances, where they wanted a programming language which would help them in configuring and programming such appliances in a much easier way. So, the language Java originated in the process. Java is a full object oriented language and it is also considered to be easier as compared to C++ from the point of view of writing bug free code. Why? Some of these points we shall see here. The reason that Java can be used to write bug free code better than C++ or C is that some features of C++ or C which often lead to bugs in programs were eliminated from Java. Some of these are: manual memory allocation deallocation was removed. So, a user would not be able to allocate memory manually or deallocate them, which was considered to be a very problem creating feature of C, which frequently led to segmentation faults, this kind of errors if there was some error in pointer manipulation. Java does not allow you to carry out any arithmetic on pointers. You use pointers in the way they should be, but do not add, multiply, subtract pointers, they are meaningless. Multiple inheritance is not allowed, this is considered to be a problem again. Operator overloading you cannot do, of course you can do method overloading, but no operator overloading, and no macro definition like hash define and type def, which can be confusing. So, these features were eliminated from Java. Java had some design goals. In the original published white paper for Java, the following design goals were specified. It was said that Java should be simple, should be object oriented, should be distributed, robust, secure, architecture neutral, portable and interpreted. Let us try to understand what these phrases or terms really mean. Java is simple. The basic concept was that the Java design white paper said that the language should be simple in design and simple to use. What it really means is that it is essentially a cleaned up version of C++. C++ as an object oriented language was already there. So, Java is a cleaned up version of that. As I had mentioned, a few of the features which are eliminated, rarely used and confusing features, some of these which were present in C++ were omitted. And the language is simple, you can appreciate it from this fact that the size of the basic Java interpreter is less than 200 kilobytes only. So, in terms of the resources that a Java program executing on a particular machine will consume, this is also pretty limited. You do not require very large memory to load and run Java programs. Even in embedded applications, you need only 200 kilobytes of memory to store the Java runtime or the Java interpreter, on top of which you can run the Java programs, right. Java is object oriented. This was one of the design goals. In fact, Java is object oriented, and the object oriented features that exist in Java are quite comparable with that of C++. Java is distributed. See, Java, one of the design goal was that it should be able to very easily write and develop distributed application, because it was also considered that Java should be a language ideally suited for internet programming, programming on the internet. So, there are some features in Java which makes it ideally suitable for developing distributed applications, like it comes with an extensive set of class libraries for handling standard TCP/IP communication. It is very easy to write client server applications in Java. For those of you who had some prior knowledge in writing client server application in language like C or C++, you will know or you will see that the effort that you need to put in to write similar application in Java is a greatly simplified one. In C, you have to write a long piece of code for communication. In Java, mainly 2 or 3 statements only to do the same thing. Okay? So, this is a big advantage. Java is robust. Robust because Java compiler is able to detect many errors that would possibly show up only during execution in some other language like C. Now, one problem we often face when you write C or C++ program is that we write a program, possibly there is some error in the program logic, but the compiler does not give any error, only during execution we get an error, segmentation fault and or some other kind of error. In Java, many of these kind of errors will be detected during compilation only. This is one advantage. And use of pointers is absolutely safe, unlike in C, where you can always be trying to use invalid pointers if there is some error in a program. In Java, it is simply not possible to access a bad pointer or make memory allocation errors, because memory allocation is automatic. There is no concept of manual memory allocation deallocation where you might make a mistake. And secondly, pointers, you are not allowed to do peculiar manipulations on pointer, like you cannot add pointers, subtract pointers, which in a sense are meaningless, but in C you can always do that without the compiler giving any kind of error. Right? Java is secure. Java is secure because the Java interpreter or the Java runtime, we shall see, this will not allow you to do a number of things that can pose security threats. This issue we shall see in some detail later, but for the time being you just understand or remember that the Java interpreter will not allow you to do the security vulnerable issues or the things which can pose as a security threat during execution. Java is architecture neutral. This means that Java programs can run on any platform, on any architecture. This point again we shall explain later. This happens because the Java compilers generate a platform independent bytecode which are executed by the Java runtime. The language Java is considered to be portable because the features of the Java are very strongly typed. Whatever you use and specify in Java, there is no ambiguity anywhere. Like for the primitive data types like integers, floating point, Java requires the sizes to be clearly specified. Binary data are stored in a fixed format across all machines. This big Indian and Latin Indian confusion keeps haunting us. You know, there are certain class of machines which use the big Indian format where the high order bytes are stored before the low order bytes, but in the little Indian format it is the reverse way, it is the other way around. So, when you are storing an integer or a floating point number in memory, the order in which they store in the two machines will be totally different. So, when you store this data or dump this data in a file, these files will not be portable across machines. But in Java this issue is not there, because in Java there is a standard and all Java implementations follow the same standard. And also strings, all strings in Java are stored in 16-bit Unicode format. So, here also there is no issue of standardization or you can say lack of standards. So, it is always Unicode. Java is an interpreted language. The Java runtime or the interpreter, as we had called, this can run on any machine or environment where it has been ported. The Java runtime is not platform independent, this will explain again. We need to have a runtime existing for every possible environment and platform like Windows, Linux, Sun, HP, etc. This Java runtime makes the Java bytecode programs platform independent. So, we shall be explaining this issue of platform independence again in detail, because this concept is very important. What makes Java programs platform independent? Why? They can run across platforms, they can be transported over internet, because one thing you understand, Java, one of the design goals of it was to have a language using which you can develop internet applications or we can use it over the internet. Now, whenever you say it is the internet, that means you are downloading or transmitting Java files from one machine to the other. So, here the issue of platform independence and portability naturally comes in. So, some features of Java are there which allows you to do this. Let us see how this platform independence feature actually comes into the picture. In Java, there is a concept of a Java virtual machine. Now, let us try to see what this Java virtual machine is. Java virtual machine is basically a Java interpreter. This can interpret Java programs, but there is one difference between the interpreter that we had for JavaScript and the interpreter that we have for Java. In JavaScript, the interpreter can take the source code and can interpret directly, but in Java it is a little different. It is something like this. Suppose you have a Java program out here. The Java program you feed to the Java compiler. Now, here again this compiler works in a slightly different way, because the compilers that we are normally familiar with, they translate a high level language program into target machine code which can be directly executed on the machine. Okay? And because the target is the machine code of the machine of the particular computer where you are running, the machine codes are not platform independent. A C program, you will have to compile for the Linux environment, you will have to compile separately for the Windows environment, separately for the Sun machine and so on. But in Java what is done is something different. the Java compiler will be generating the object code in some intermediate format. This is called bytecode. Java bytecode. Now, Java bytecode can be considered to be equivalent as it is the machine language of a hypothetical machine which does not exist, but it is a simple enough machine for which the compiler can easily generate code. Okay. So, Java bytecode is basically considered equivalent to the machine language of a hypothetical machine. That is why the concept of this virtual machine comes in, right. So, as I said, the Java compiler transforms a Java source program into bytecode. Now, the Java virtual machine that we are calling, that is sometimes also called Java runtime. This is basically the Java interpreter which will take the Java bytecode and execute them directly or interpret them directly. Now, let us again come back to this diagram. Now, you see this Java program is something which you have written. This compilation you can do on any platform you want. What you know that this bytecode that you generate, this is a standard bytecode. This is defined by the Java standard. This bytecode will be platform independent, okay, because it is defined according to some Java standard. Wherever you compile, whichever compiler generates the bytecode format would be standard. You can easily take it from one machine to another without any problem. But the point to note is that what you have after that is the Java virtual machine, this portion. Now, JVM is not platform independent. What is JVM? Java virtual machine, as I said, this is also called Java runtime. This is essentially a Java interpreter which can interpret Java bytecodes. Now, this Java interpreter must be actually running on the different computers on the different platforms. So, you should have one version of Java virtual machine or Java runtime running on Linux, one version running on Windows XP, maybe another version running on Windows 2000, another version running on Sun Solaris, another version running on HP UX, and so on. For all the target platform, you must have separate versions of Java runtime installed and running. Fortunately, Java runtime is available on almost all platforms today. All you have to do is simply download and install Java runtime. Java runtime gets installed as an add-in to your browser also, so that you can run Java program in your browser itself. So, once you install this Java runtime on your machine, Java programs now become totally platform independent and can run on any machine. If a machine where you are downloading a Java program has the runtime, it can execute there without any problem. And this is how platform independence is achieved. There are two things. First thing is that the bytecode which is platform independent and portable. Number two, the Java runtime which is pre-installed on all the platforms. Java virtual machine is not portable, okay, but the Java bytecode is. This is how we manage or handle the problem or issue of portability of Java programs. So, this diagram which is shown here actually iterates the same point I am trying to make. The Java compiler will be generating the bytecode which can execute on any platform. It can be Java runtime on Windows XP, Java runtime on Linux, Java runtime for Sun Solaris or any other. Okay. So, this is how Java programs get executed. Now, Java is the language I mentioned which is considered to be very suitable to be used in the internet scenario. Let us try to understand here that why people say so. Now, for use in the internet, there is something called Java Applets that we need to understand. What are Java Applets? Normally, when you write a Java program, they are called applications, Java applications, but Java programs to be used in the internet scenario as part of web pages, they are called Java Applets. So, basically Java Applets are Java programs which can be embedded within an HTML page. Applets exist in bytecode form on the server and applets are downloaded by the browser, executed on the client machine. So, what I have said is this, let us try to understand. This is your web server. This is a web server on which we have a particular HTML page. This is an HTML page, and there is also a Java program which is stored on this server. This is actually Java bytecode after compilation, and from this HTML file there is a link to this applet. We shall see how, Java bytecode. Okay. Now, from the browser, suppose this is your browser, from here you are giving a request to download this web page. So, when this web page will be downloaded and displayed on your screen, following this pointer, this Java bytecode will also get downloaded, right. So, now what will happen is that you will be having a scenario where you have a page being displayed on your screen with a Java applet inside it. So, the Java applet can now execute within the browser itself, within the web page itself. Now, this Java applets can be used to provide highly interactive and animated web pages, which makes the web page design pretty interesting and attractive. Now, if you compare Java applets being downloaded on the browser and executed locally versus CGI scripts, the advantage is that response will be better because applets run locally on the client machine. Now, again another question might bug you that, well, there are many things I can also do using JavaScript, I can also do using Java, which one is better? Now, here there is a trade off. If the thing if you want to do is simple enough, it involves few line of codes, possibly JavaScript is better, because you will have to download JavaScript or Java whatever from the web server to the web client. If it is embedded JavaScript, you need to download the file only once. But if it is a complex application, like a very complicated animation which demonstrates the functioning of some protocol, for example, graphically you can see on your screen how the TCP protocol functions. This kind of a thing, it is much better and natural to have it coded in a Java program, because in JavaScript you simply cannot do this, and put it as an applet that will be downloaded along with the page, and you can see the animation playing on your screen. Okay. So, the response will be much faster in general for Java programs. This is how you can embed a Java applet within an HTML document. You use the applet tag. The syntax is this. There are some other attributes also, but these are the minimum attributes you normally use. The first attribute says code. Code gives the name of the bytecode file. By default, the bytecode file have an extension of dot class. Java programs have an extension of dot Java. When you compile them, you get a dot class file, that is the bytecode. Okay. So, you specify the name of the bytecode file to be included, you specify the width and height of a sub window inside the window. That means, this is your window on the browser, and you can specify, here is some HTML document being displayed, you can specify in between that this is an area where I want my applet to be executed. Okay. So, I must specify the size of the applet display area in terms of the width and height. This can be specified as part of the applet tag. I can give width equal to 300, height equal to 50 for example, these are in pixels, and applet tag will end by the end applet tag. In between, I can have one or more parameter statements param, through which we can pass some parameters to an applet from the HTML file. We shall see some examples later. Now, the question arises, why do we need applets? Isn't Java applications which I had talked about earlier, is it not sufficient? Can't we do all these things using applications? Why do you need a separate kind of Java programs called applets? There are reasons. The first thing is that there is no doubt that Java is very convenient for graphical programming. There are a large number of libraries, utilities and methods available for programming involving graphics, interactive applications and also network programming. All these three things can prove to be very attractive for developing applications in the internet scenario, because in the internet scenario you actually have to deal with all these things. You need to make your pages more attractive, you need to have very efficient network programming to transmit data. Suppose you think of an application, typical application, you are developing some multi-party online game using Java. There are a number of people which are spread all around the globe, they are actually playing among themselves. But during the time each of the player is making a move, the data corresponding to the move has to go to some central server. From there some response again has to come back. So, there is continuous communication that need to go on between the client and some central server. So, for these purposes network programming also becomes very essential. These are the capabilities of Java, and we actually require and need Java to do all these things. We need applets also, because applets are something which is different from Java applications. Java applets, this concept allows us to download Java programs over the internet and run them on the browsers themselves. Java applications cannot run directly on the browsers. Java applets can run on the browser, because for Java program to be run on the browsers there are several things to be handled, like I can move forward, backward, scroll up, down. So, what happens to my Java program running? But when you are running a Java application, it is only that Java program you are running, nothing else. But in a web page there are so many other things, there can be multiple Java applets, there is an HTML document to be displayed, so many things are together. Okay. So, how to handle it in a browser? These are some issues to be addressed. And applets, as we will see, due to their features you can use them to design attractive or interactive web pages. Now, using Java applets you can develop web based applications. Now, by web based applications, well, I do not try to limit your imagination, it is up to imagination what are the kind of application you would like to develop on the web. Now, I can just mention a few of the interesting applications. The client computer from where you are accessing the internet can have just the Java virtual machine. It can be your computer, it can be your small handheld iPod kind of device which has the capability of connecting to the internet and download Java applets. In fact, some of today's mobile phones also have the capability of downloading Java applets. They can execute directly on the mobile device, right. So, you think of a situation where in the client computer you have only the JVM installed and users, depending on their requirements, can download any application or utility they want and use them. This application can be a word processor, it can be an email client, it can be a game, it can be whatever. Now, in this kind of a scenario, you need not install any special software or programs on your computer. There are many such machines which have been developed or built based on this principle. The machine has minimal configuration in terms of both hardware and software. Whatever you need, you simply download from some server and run them. This is the basic concept. So, these are some advantages which Java applets provide. Subsequently, Microsoft have also come up with, you can say, an answer to Java, a language called C#, which looks somewhat very similar to Java in terms of its capabilities. C# like Java can also be used for developing internet applications pretty easily. Security issues become very important here. You see, we are talking about Java applets. We are talking about Java applets being downloaded from some web server into my own machine. I do not know what that applet is doing, okay, but I am worried about the security of my machine. I would not like that some virus goes into my machine. I would not like that someone can extract some sensitive information from my machine, from my file system. So, when I am downloading an alien code, a code which I have not written, someone else has written, I am downloading that on my machine and I am executing it, I must be absolutely sure that executing that alien piece of code will not do any harm to my machine. Okay? This is very important to understand and assess. So, the main security issue, as I have said, this arises from the fact that applets are downloaded from a remote server and executed locally. There are some restrictions which apply when applets are executed, which automatically ensures that security is not tampered with or is not breached. An applet cannot call any local executable file. This is not allowed. An applet cannot read or write into the local file system. This is not allowed. It can communicate with only the web server from where they are downloaded and not with any other host. What this means is that, suppose I am visiting a website xyz.com, I am downloading an HTML page along with an applet from there. The applet was residing in xyz.com. Now, inside the applet there is some network programming. It is contacting some other program somewhere and is communicating some data. Now, what the constraint says is that this applet can only initiate a communication from that xyz.com website from where it was initially downloaded. It cannot start a communication with some other website abc.com. Okay? So, these are some constraints. So, due to these constraints, obviously an applet cannot access sensitive information from the local machine. Like in some local machine, in some special file, the user's name, email address, all these things might get stored. So, if a malicious applet can access this information, they can send all this information to some central place from where they can get some information which otherwise you would not have liked to disclose to others. Okay. But due to the restricted environment under which applet runs, due to the capabilities of the Java runtime, these security issues are not that important. So, you cannot have malicious code in Java applets. You cannot access any memory location outside your area. These are ensured automatically because Java is always executed in the interpretive mode. The Java runtime always has the control and it executes the Java bytecode instruction by instruction. So, this is considered to be a plus point for Java, but other alternatives which people use like ASP or some other technologies, there it is possible to write malicious code rather easily. So, whenever you are installing some antivirus or some kind of a personal firewall, you have to make a lot of configuration there to check for these kind of contents to ensure that they do not have or contain any malicious content. But in Java you can be absolutely sure of, a Java program can never contain anything which can be harmful to your computer. Okay? Fine. Now, let us come to the point Java applications and applets, what are the exact differences from these two? Well, we shall see later more formally that how an application can be converted into an applet, but simplistically speaking, Java application is a standalone program. They are standalone programs just like any native program. Native program means, say I write a program in C, I write a program in C++, I compile them, I execute them. They are standalone programs which are running on my machine. Java application work in a somewhat similar way. You can compile a Java program as Java C, which invokes the compiler, and example.java is the name of the Java source file, and after compilation you get this example.class, which is the bytecode file. To execute the Java program, you have to invoke the Java runtime whose name is just Java. You call Java with the bytecode file, the program gets executed. As I said, the Java bytecode file is portable. You can simply copy this Java bytecode file example.class to any machine, any platform, and you can execute it there. The program will execute correctly. Okay. So, a typical Java application looks like this. This is the simplest possible Java application, which simply prints a line of text on the screen, thank you, followed by a new line. There is a class called example, and within that class there is a single method called main. For a Java application, there has to be a method called main. This is mandatory. But we will see here there is a little difference from Java applet. In a Java application, we must have a method called main. Java applet in contrast is not meant to be executed in a standalone fashion, just like in the previous show we are executing a Java bytecode by giving the Java bytecode file this kind of a command. Java applet are meant to be downloaded along with a page, web page, and executed along with it. Okay. Of course, for testing out applets you have written, there is an application which was developed by Sun again called Applet Viewer for running specifically applets on a window. Now, some differences are there in a Java applet as compared to a Java application. This does not have a main method, and it must have an associated HTML file from where it has to be linked. and if you want to execute a Java applet say from applet viewer, you must call it by the HTML file name, okay, not by the dot class file, not by the bytecode. So, applet viewer is actually an utility to view the complete HTML document along with the applet, not just the applet. Okay. So, you need to invoke the HTML file with applet viewer. Similar thing you will do when you are including the applet inside an HTML document. Now, a simple Java applet will look like this. Now, we shall see these details later, how to convert an application into an applet in our next lecture. At the beginning, there are some special libraries to be included, so as to have applet. And if you compare this with the previous example here we had a class example and we had a main function, main method. Here we had also, here you have also a class whose name we have given as example 1. This class is inherited from the master class applet, and this does not have any method called main, but rather it has a method called paint. There are some standard methods available in applet like init, paint, redraw. We shall see this later. This takes as parameter a graphics object G, because in applet whatever screen area is available to you, that is considered to be a graphic object. You can display anything on that graphic object. So, drawString is a method which is present in the graphic object G.drawString. You can call this to display this string, and this represents the actual coordinate where you are displaying. So, in this way you can write a simple Java applet which is somewhat similar in capability to the application we had just seen. And to include this particular applet from HTML file, the corresponding HTML file will look like this. There is an HTML file where in addition to the HTML code, you have the applet tag. Code will be example1.class, width and height are specified of the window where the applet will be running. One thing you remember here, that when you write a Java program, the master class, here the name is example1. The name of the Java program has to be example1.java, and the name of the bytecode will be example1.class. This is the convention which is followed. Okay. The same name of the class name you use as the name of the file. Okay, so, this is how the HTML file looks like. Now, let us look at the general syntax of the applet tag. There are actually so many fields and attributes here. So, let us try to see what these attributes are. Applet code we have already seen. There are other attributes, we will explain this, the purposes. Width, height, code base, these are all optional. All fields within square brackets are optional fields. Code base, alt, name, align, v space, h space, these are all parameters. Some of code width and height are mandatory, others are optional. After that, you can have as many number of parameters as you want. The syntax is param name equal to name of the parameter, value equal to value of the parameter. This we will see an example for this later. And after this, you can have HTML, some HTML code here, because you know all browsers may not be supporting Java. If it supports Java, if it has the Java runtime installed, then the applet can be downloaded and executed. But if your browser does not have Java, then there is no point in downloading the applet. So, in that case, whatever HTML statements or code lines you have after this param, they will be displayed as it is in place of the applet. Okay? Fine. Now, let us see what the different attributes of the applet tag specify. Code we have already seen in the example. It specifies the name of the applet class file. Now, when you are specifying the applet class file, subdirectories are not allowed. Like you cannot write xyz/example1.class. You will only have to write example1.class. Okay? Subdirectory specifications are not allowed here. But how do you specify subdirectories if they are present? You can specify them by using the other attribute called code base. Code base can be used to specify the default directory where the applet is to be found. So, in code base you can write code base equal to xyz/abc/ whatever, where the applet is to be found, and code will actually contain just the name of the bytecode or class file, right. So, in general this code base can be a URL pointing to any web server. So, here there is a point you should remember, that I am downloading an HTML file from a particular web server. In that HTML file, code base points to some other web server. No problem, I am allowed to download the Java applet from that some other web server. But the only constraint I have here is that Java applet I have downloaded can communicate only with the web server from where it was downloaded, not from the web server from where I had got the HTML file. Okay. So, some Java applet which is stored in some other site, I can also include them in my program, in my code HTML document. So, in code base you can have a URL which can point to any web server in general. Okay. Alt is an attribute using which you can specify a text message. Here this attribute is used for a purpose like this. Suppose the browser understands applet, but due to some reason it is not able to execute, due to insufficient memory or some reason. So, whatever text is present in the alt, that text will be displayed in place of the applet. Width, height are mandatory fields. They specify the size of the applet window or the applet display, and these are specified in pixels. Name, sometimes you need to specify the name of an applet. Now, when we were discussing JavaScript in our previous class, we had mentioned that when you want to call a Java applet from within JavaScript, you need to include that Java class object by its name. It is this name attribute which you should use for the purpose. In the applet tag, whatever name you have used, this name you will have to use for referring to that particular applet. Moreover, you can use this name for inter-applet communication. Two or more applets on the same page, HTML page, can communicate with each other. For example, if we want to access an applet subclass applet_a, whose name I have given as ONE1, this name equal to 1. Okay. From some other applet on the same page, we can write a statement like this: get applet context dot get applet within bracket name of the applet. So, here we can get hold of the applet which we are wanting to access, we are assigning it to a variable p of type applet_a. Now, using this p, we can access any public methods or public attributes of this applet1. Okay. This align, this specifies the alignment of the applet. See, we have specified the applet window, but we have not specified whether the window has to be centered, it has to be right justified, left justified. All these things we can specify by the align keyword. V space, H space, this specifies the margin. See, it is like this: you have specified the size of the applet window. Okay. This is the width and the height. this is the width, this is the height. In addition, what you can specify some margin which has to be kept on the four sides. Okay. So, this margin you can specify, margin in the horizontal direction, how much margin you will keep. Similarly, in vertical direction, horizontal direction, both you can specify. These can be specified by using these V space and H space attributes. Okay. Param value, as said, we can use this to pass some values to an applet. Let us see through an example how we can do this. Suppose in the HTML page we have included an applet like this, applet tag code equal to exam.class, this is the name of the bytecode file, width 100, height 100, and there are 3 parameters we are passing. Say the names of the 3 parameters we are giving as S name, a student name, short form for student name, S name, roll number, color blind, whether the person is color blind or not, and you are also passing the value for the S name we are passing value as Tarun Mitra, for roll number we are passing the value as 99213, for color blind we are passing the value as false. So, there are 3 parameters we have passed where we have specified the names as well as the corresponding values. Okay. Now, from within the Java program, this is some statements which are present inside the Java program. Okay. Now, this param name value whatever we had said, those are present in the HTML file from where the Java program is linked. Now, inside the Java program you can have statements like this: get parameter S name, you assign it to a variable name. So, actually that Tarun Mitra will get assigned to name. The roll number, you are again doing a get parameter roll number, you will be getting or retrieving the roll number value here. This will be obtained as a character string. So, in addition you have to call integer dot parseInt to convert it into an integer, assign it to roll. Similarly, again color blind is the third field, you will be getting the value false, get parameter, boolean dot value of, if you call this will be converted into a boolean value which you assign. So, here you see the simple code snippet in Java where you can access the parameter values passed through HTML and you can assign them to some Java variables which you can use in whatever you want after that. Okay? Fine. Now, let us very quickly look at some applet examples. We shall continue with some examples in our next class also. This is a very simple example which will draw some lines. Public class, this is the name of the class, and as you can see here also we have a single method called paint. So, whenever an applet runs, it is this paint method which gets executed automatically. So, by now you should be able to understand this. And in this for loop, the values of i's are changing and you are changing the value of this x and y coordinates and we are drawing some lines. So, you will be getting a set of lines drawn on the screen. Okay. So, this is just an illustration of drawing lines. This is another example which shows you how you can play a sound clip in Java. So, these are the headers, public class play sound. Here you have written a function or method called init. There is a try catch block which is standard in Java, catch is the exception handler. In the try block you are creating an URL, new URL, you are assigning it to a variable called sound which is also of type URL, right. and here in catch you call the exception handler with the type of the exception if the URL is not properly formed, and after you get this you simply play sound. So, whatever URL is there, that will be played and the sound you can hear. So, play is a method which is built in. Display image, again this is another example. So, here is similar, this image picture null, again you have the init function, again in URL you store a URL slash logo.gif, and you can use the function get image to display an image. This you can store in pic. So, there are some examples of some applets, we shall see later some complete examples how we can use these. This image update, paint, all these things will be there, part of it. So, I am not going to the detail of this right now, we shall come back to this later when we talk about examples on applets, what are the different methods in applets, why are they used, and so on. So, let us stop our discussion on Java applets today here, because in the next class we shall be talking about how we can convert applications into applets. Only then you will be able to appreciate what are the different methods that are present in a Java applet and in what context they are invoked and used. Okay. So, I am leaving the explanation for those detailed functions, invocation, their order for the next class. Before that, let us look very quickly at the solutions to some of the questions we had raised for the previous lecture. The first question was, how do you store and retrieve the value of a cookie? So, the example we had given, we can assign some string to a document.cookie attribute, and the value assigned should be of this form, cookie name equal to the cookie value. This escape document last modified returns the value of the last modified, the date. Okay. This escape actually removes all the white spaces and special characters, converts them into escape sequences. How do you access a Java applet from JavaScript code? This we had seen also. The applet, when you are creating in the applet tag in the HTML file, you can give a name attribute to it. For example, the name is my applet. Then you can access that Java applet in JavaScript by referring to the object as document.myApplet, like this. What do the window and document object represent? This again I have explained repeatedly. Document object represents the HTML document, whereas window object represents the window or the frame where this document is being displayed. Okay. How do you change the background and foreground colors of a document? By using the BG color and the FG color attributes, we can set them to any desired color. So, background and foreground colors can be changed. So, some questions from today's class. Why is Java considered to be secure? What makes Java programs platform independent? What is the difference between Java bytecode and Java runtime? What is the difference between a Java application and a Java applet? How can you pass parameters to an applet from the HTML page? Is it possible to invoke a method of some other applet from another applet on the same HTML page? So, with this we come to the end of this lecture. Thank you.